Hi, this is Alex from devstories.eu. Pydantic, Data Validation, Episode 11 of 20. Checking if a string looks like an email format is simple. Verifying that the data meets strict business logic, like cross-referencing an external system or enforcing specific mathematical rules, requires a safe place to run custom code. That is exactly what post-processing with after and plain validators provides. When you define a field in a Pydantic model, the library automatically checks the input against the type hint. Types only take you so far. An integer is an integer, whether it is 1 or 1,000,000. To enforce rules beyond basic types, you add custom validation functions. Pydantic allows you to inject these functions into the validation lifecycle. The most common injection point is the after validator. As the name suggests, this runs after Pydantic finishes its internal parsing and type coercion. Here is the key insight. When your custom function receives the data in an after validator, Pydantic guarantees that the data already matches the field type. You do not have to write boilerplate code to handle type conversion or catch unexpected data types. Consider a scenario where you need to ensure an integer field is an even number. You define a model with a field typed as an integer. Then you write a custom function that takes a value as an argument. Because you configure this function as an after validator, you know the value is absolutely an integer. You simply use the modulo operator to check if dividing the value by 2 leaves a remainder. If the remainder is not 0, you raise a standard Python value error with a custom message. If the remainder is 0, you return the value. Pydantic takes that returned value and assigns it to the model. The division of labor is clean. Pydantic enforces the type, and you enforce the business rule. Sometimes Pydantic's default parsing gets near way. That is where the plain validator comes in. A plain validator completely replaces Pydantic's internal validation for a specific field. Pydantic steps aside and hands the raw, unvalidated input directly to your custom function. You use a plain validator when the standard coercion rules do not fit your use case, or when you're dealing with a highly custom data structure that Pydantic does not natively understand. In this scenario, your function is responsible for everything. It receives the raw input, performs any necessary type checking, converts the data, and applies business logic. If anything fails, your function must raise a value error or an assertion error. If it succeeds, it returns the final, clean value for the model. You attach both of these validators to fields using Pydantic decorators on class methods or by adding them as metadata directly inside the type hint using annotations. The choice between them comes down to how much of the work you want to do yourself. Use an after validator when you want Pydantic to do the heavy lifting of type conversion, and reach for a plain validator only when you need absolute control over parsing the raw input from scratch. Appreciate you listening. Catch you next time.